Okay, I'm not sure. We'll have to go through a lot of questions. We have very little time. A stone is projected horizontally in a vacuum and moves along the path shown. X is the point on. Oh, you're trying to. All right, Boxes, you into.
Oh, nah, I'm not.
X is a point on this path. XV and XH are vertical and horizontal lines respectively through X. XT is the tangent to the path at X. Tangent. This is vertical. This is horizontal. Right? Pretty much easy. Along which directions do forces act on the stone X? Right. Right, so the answer is B. Let's just do a quick explanation to why it's B. It's because there's only one vertical component, which is weight, mg. And there would have been air resistance, but they specifically didn't ask about that. So because we know that, because they said the word vacuum, and it's because of vacuum that there's not going to be any air resistance. And T is obviously not going to be the answer. That would have been a resultant if you had certain things. And obviously, air resistance would act in this direction if there was any air resistance. So the answer is XV only, and this is Sadia. Sadia got this. Right, let's try again. Try this one. The dotted lines. Nishlian, are you ready again? Oh, good. Oh, good. The dotted line shows the path of the competitor of a ski jumping competition. Ignoring air resistance, which graph best represents the variation of speed v with the horizontal distance x covered from the start of his jump at P landing at Q? So what's going to happen? Basically, they want the velocity. So the velocity is going to slow down as it moves up, and at the highest point, the velocity is not going to be zero. Why is it not going to be zero? Because you still have a horizontal component. If it was zero, it would just drop dead from here, right? But that never happens. It keeps on going like this. So which means there's a non-zero velocity at this point. And then it speeds up again because it's losing GPE and gaining kinetic energy. So the answer is D. So you might ask why it's not going to be C, because obviously the velocity is dropping to zero here, which is not happening. If that did happen, it would just hit the ground. And all right, moving on. Next question. Da-da-da-da. Oh, here's the chocolate for the question. This is fun, man. All right. Cyclist pedals blah 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 horizontally, air track 2 meters lower, right? So basically he's going at a constant speed of 6 meters per second, 2 meter drop, and then it hits the ground. So what happens? The cyclist travels the horizontal distance of 6 meters in the air resistance is negligible. What is the horizontal velocity v of the cyclist at the end of the higher track? So, Nishlian?
I have no idea.
You don't know any idea why you say this. So, one of the things I know, it's covering 2 meters vertically, and in that time it's covering a distance of 6 meters horizontally. So basically what's going to happen is this drops a distance of 2 meters. We need to first figure out the time required for it to drop 2 meters. So we're going to use the equation h is equal to half gt square, right? Where did this equation come from? Nishlan, can you tell us where this equation came from? H is equal to half gt square.
Yes.
Yes, tell us.
S equals to ut plus half at square.
Excellent. S equal to ut plus half at square. That's right. So that basically makes us S is basically h half gt square. From this we can solve to find the time t. Once we find the time t, we know in the same time it's covering 6 meters. So it's going to be basically velocity is distance by time. Distance is going to be 6 and time is going to be whatever we get here. Next question. I think these guys can do this. Let's skip this one. All right. This is similar to what we just did a few moments ago, so we can skip this one too. All right, 6. I'm not giving a chocolate for this one because it's far too easy. Hey, okay, let's get to this. A tennis ball is released from rest from the top of a tall building. This is an easy question. Nobody gets a chocolate. Nishlian, this is your chance to shine. Which graph best represents? Now, guys, I'll just say it out clearly. Nishlian is one of my favorite students. She's my second favorite student, actually. So yes, let's move on. Huh?
Who's the first?
Well, you're not going to know that. Which graph best represents the variation with time t of the acceleration a of the ball as it falls, assuming the effect of air resistance is not negligible? So, if air resistance is not negligible, what they basically want is a graph which shows how acceleration varies with time. So, this is basically a concept of terminal velocity. So, if we were to draw the terminal velocity graph of velocity versus time, everyone knows this, I believe. The graph goes like this, right? It becomes flat. Not a good diagram, but good enough for now. Well, this is the terminal velocity. So the acceleration drops to 0. Where does it drop to 0? When you reach the point where air resistance is equal to weight. And where do we get this in these graphs? The only one which is approaching this most closely is D. And that's the answer. Yes, Abdullah Ismail, you did get that right, but no chocolate for this question because it's too easy. Right, moving on to this question, question number 7. Projectile is launched at 45 degrees to the horizontal with initial kinetic energy E. Assuming air resistance to be negligible, what will be the kinetic energy of the projectile when it reaches the highest point? We did talk about this the other day, yesterday actually, right, Maqsadul?
I think so.
Oh, you think so? Yeah. Do you want to do a calculation? What's going to be the value of cos 45? Could you tell us, please?
Cos 45. It's root 2 by 2.
Root 2 by 2. So basically, if we consider this is a like bad diagram, I can't say bad words right now. But anyway, so this is theta. So theta is going to be 45. So this component is v cos 45. And here the velocity is v. At the highest point, the velocity is going to be v cos 45. Right, Nashlian?
Yeah.
Do you agree to this?
Yes.
Right. So basically what happens is if it's v cos 45, cos 45 has a value of 1 by root 2. Or as you said, 2 root 2. So basically the kinetic energy here is going to be half mv, which is v into 1 by root 2 square. So this gives us half into half mv square. So basically the kinetic energy drops to half of its original amount. And if that is the case, then your answer is going to be 0.5 E. Yes, a few of you guys actually got the answer. Good job, guys. So yes, a quick point I'll add to this is if 50% of the energy became kinetic or is remaining as kinetic, then 50% of it is going to be gravitational potential. Yes, all right. Ragator answer was D. Stop falling asleep, Talha. All right. Okay, this one is going to get a chocolate. Neshlian, this is your chance. Here's a chocolate. Right, and let's try this. The stone is projected horizontally at time 0 and falls. Projected horizontally at time 0 and falls. Air resistance is negligible. The stone has a horizontal component of velocity Vh and a vertical component Vv. Right? So, which graph shows how Vh and Vv vary with time? Tricky question, tricky question. So, we must consider that air resistance is negligible. Please note that. Let's circle that. Air resistance is negligible, so we don't miss it out. So what happens if air resistance is negligible? Can you tell us, Neshlihan?
What?
What's going to happen if air resistance is negligible?
VH stays the same.
Yes, horizontal velocity will remain unchanged. And what's going to happen to the horizontal component? Sorry, constant. What's going to happen to the vertical component? It will, what's going to happen? Come on.
It's gonna...
Damn, man, these guys are on fire.
সবাই পেরে গেছে
সবাই আনসার করে আলাইছে তুমি কোশ্চেন পড়তে পড়তে সবাই আনসার করে আলাইছে
answer বলো
Well, yeah, you're sitting upside down and everything, but like, you know, I'll give that to her. And yes, Sadia gets this. Answer is A. Sadia is on fire. Sadia.
Oh, increases.
Yes, so basically why is this the answer? Because imagine if the object is falling like this. What's going to happen is the horizontal component of the velocity horizontal, I hope the Ferros is not blocking the view. So the horizontal component remains constant because there's no force acting on it. And vertically, the velocity constantly increases. Velocity vertical. Why? Because it's accelerating at g.
That's right.
Right. So it will increase uniformly, the vertical component, and the horizontal component will remain constant. So if that is the case, what we see here is this remains increasing and this is constant. While this is the velocity horizontal is actually increasing and the velocity vertical remains constant. This is not what happens. It's exactly opposite. And here we're seeing the vertical velocity increases exponentially. That doesn't happen because the gradient of this graph is acceleration. This means it's moving at an increasing acceleration, which does not happen either. And this, what's this, man? What's going on? Vertical velocity drops to 0. This is like, you know, something is falling really fast and then slows down and just hangs there in the middle of the air. Like, you know, I really don't know if that happens. But anyway, yes, Sadia, this is yours. Congratulations, you got this chocolate. Neshlian, you're going to go home hungry tonight. But I loved how everyone answered this, like, you know, pura lightning round. Dekho, ekdom Sadia A bollo, tabor dham 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 kore sob, like, you know, Shamin Safa A. Shamin Safa, you missed it, man. Abdullah Ismail A. Achu, তারপরে হইতেছে Hasin Hamid A. Zunaiddin A. I get another chocolate. Yes, you do get another chocolate. Samin Rahman C. Oh man, no, it's A actually. Sadid Arham Hussein A? Question mark. More confidence, man. We need more confidence. And yes, too late. But yes, good job so far, guys. Good job so far. I'm proud of you guys. I'm really proud. All right. Yes, Nestleon's already reading this one. Tennis ball thrown horizontally. No chocolate for this. It's easy. Air from top of a tall building. Air resistance is not negligible. All right. Look at that. Look at that. Look at that. Not negligible. What happens to the horizontal and vertical components of the ball's velocity? Horizontal component of velocity. Horizontal কোন দিকে জানো তো? এদিকে.
Are you sure?
Yes. You want to get your calculator out for that? So horizontal velocity is going to be এরকম. So which one is it going to be? It's going to decrease to 0. Right? It's going to be 1 or 2, any one of these. And what happens to the vertical component of velocity? We think about this like terminal velocity. What happens is the velocity increases and then becomes constant. Vertical is in this direction. So it's going to increase, but it will stop increasing when air resistance is equal to weight. And which one gives us that answer? Increases to constant, increases at a constant rate, no. Increases at a constant rate, no. Answer is D. Okay, this is a good question. This is a legit good question.
This is a legit question.
So I'll just tell you how to do this sum. I won't solve the entire sum here because we have a lot of work behind the sum. So basically what you have to do is, you know, the initial velocity u is equal to 0 here, and you know the acceleration is going to be g, right? So two markers m1 and m2, vertical distance h apart. So this is going to be t1 basically when it crosses this point. It's going to be t2 when it crosses this point. The distance here is x, distance here is h. The common mistake that students make is they make two equations. They try to solve this simultaneously, which is part of the answer, but the mistake they make is they make one equation for x and another equation for h, which is not supposed to be the answer. The method is you make one equation for x and you make another equation for x plus h. Why? Because you don't know the value of the velocity here. So for this, even if you do make an equation for h, you end up finding another question. What is the value of the initial velocity at m1? And you're really confused and everything. And because we have h, basically s, a, and we have the values of t, which is t1 and t2, the best thing to use is basically s is equal to ut plus half t squared. Right? So basically we're going to make two equations for this. One of the equations, I'll just move down here because there's a little more space. I'll come up to it again. So one of the equations that it's going to be is for x. So for that, red, okay, red. Nestleon said red. So for that, x is equal to ut. U is going to be 0, right? The initial velocity is going to be 0. And t is going to be t1, right? So ut, so basically 0 into t1 plus half a t1 squared. So that's going to be one equation. And the second equation is going to be x plus h. So that's going to be s, which is x plus h, is equal to ut. Again, that's going to be 0 into t2 plus half a t2 square. Right? So it's just 3 steps from here. If you move on with the working, you will see that you eliminate x. You make x go away. So you'll end up getting D as the answer. That's how you solve for this question. And that is how you answer this.